Welcome back to this beginner series for programming in Rust. Now, so far we've used the types that Rust gives us. In this video, we're going to start defining our own types. The tool for this is called the struct, which essentially groups related data under one name and gives each piece a label. We then attach behavior to our data using something called methods. Now, structs, together with enums, which we've explored in previous videos, and we'll do so in greater depth in the next episode, are essentially how you model everything in Rust. So in this episode, what we're going to do is we're going to define and create our own structs. We're going to look at some shorthands which help cut down repetition. We'll also meet tuple structs and also unit structs. And then we'll also learn how to write methods and associated functions to those structs. So to begin, I'm going to open up a terminal and we're going to create a new program. Cargo new, we'll just call it struct. And if we open up our file explorer, we can see our struct program along with our main.rust file. And we're just going to work in this file and get rid of that boilerplate. Now, a struct definition essentially lists the fields and their types. So when we use it, we define one, we then create an instance of a struct, and then we can read fields using dot notation. So let's take a look at that. All right, so let's run our program. Just open up my terminal again. I'm just going to cd into my right directory and then run cargo run. It's building up and there we go. There I'm printing out my account. So essentially what we've done here, we've defined an account with 3 fields. So a handle, an email, and whether I'm verified. Then in our main function, we've created an instance by giving every field in our struct a value. And then when we've printed it out, we've printed out the properties by reaching into it with dot notation. So this example, account.handle or account.email. So account is really the type, and then your properties are accessed through dot notation, which is fairly simple. Now, there are 2 handy shorthands that we can use when working with structs. So, for example, when a function parameter has the same name as a field, we can actually skip the repetition with field init shorthand. So, for example, let me write out the following. Right. Because the parameters are already called handle and email in this make account method, or function, sorry, we write each name only once. There is also struct update in syntax that you can use. So for when you want to create a new instance, that's mostly the same as an existing one. So the way that we can do that, I'll go into main and write the following. So the 2 dot account line here, what that essentially means is fill in every remaining field from account. So up here, I've got the handle and verified there. So account 2 is actually going to get this updated email. So rather than will@example.com, it's going to be willvalida@example.com. And let me go ahead, just update that. So hopefully when we go open up the terminal again, cargo run. So there you go. There's my updated email from this account to email property now. So everything's remained the same. So scroll up, I've got my previous run, so Will Valida, and I'm also not verified. I'm also still Will Valida in account 2, but I've updated my name to, email, sorry, to willvalida@example.com. So it's got my full name this time. Let me just get out of my terminal and let's talk about 2 quick variations of struct. So the first is a tuple struct. Now it has types, but no field names, which is really handy if you're building very small, lightweight wrappers. So if I go struct point, I can give it 2 types of integer 32, and that's my tuple struct. There's also a unit struct as well, which have no fields at all. And you might think, well, that just sounds really useless. All it is this. struct marker, and that's all it really is to it. But this will become useful when we attach behavior with traits, which we're going to cover a little later on in the series. But just keep in mind that this is what we call a unit-like struct. Now we can attach behavior to structs using methods and associated functions. So to attach behavior, we're going to write an implicit block. This is a method that takes itself as a parameter, that self being the instance that it's called on. So let's write some code. All right, so let me run this by opening up a terminal. I'll return to my original terminal. I'm in the right directory and cargo run. And there we go. So the floor area, I'll just get some more real estate and go back up. So our floor area takes an ampersand self, and that's a shared reference to the room, and it will return its area. We call it in our main method with a dot, so room.floor area. Now square doesn't take itself in, so this is what we call a associated function that works like a constructor. We call it with the double colon here, room : square, and capital self, just go back up here, that self there is essentially shorthand for the type that we are in. Now notice the line that we've got above this struct. We're essentially deriving debugging here. And that's one annotation that tells Rust to generate printing code, which you can turn on with the debug formatter. So if I come back down here, and I'm just going to print some lines out. So if I open up my terminal and cargo run, essentially what's happening here, the first will print the room on one line. So there's our first print statement or debug statement. And then the second with a hash prints across several lines. And this is really good for inspecting larger values while you're working. So if you've got a large struct and you want to do some debugging on it, this is really handy to actually see what that struct currently looks like. Okay, so before we finish this video, let's recap on some of the key ideas that we discussed in this video. Now, structs are how you start modeling the real world in Rust. So these are going to show up quite often in your Rust projects. Essentially, a struct groups labeled data together. So instead of having to juggle around loose variables, you essentially bundle related fields under one type. And each field has its own name, so the meaning is quite clear in the context of the struct. Now, shorthand syntax saves typing. We can do field init shorthand, which will let us write a field once when the variable already has that name. So you already have a struct, and then we can perform updates on part of that struct, so we don't have to use the entire struct or the entire value, and we can only update the things that we need to update. We also looked at tuple structs and unit structs, which are lighter variants of structs. So remember, a tuple struct is used when field names wouldn't really add much, and we can use unit structs when you need a type but no data within that struct at all. We also took a look at methods and how they add behavior to structs. So we looked at a function written in an implicit block, which essentially took itself, and then we could call methods on that with dot notation. We also looked at associated functions and how they act like constructors. So a function in the implicit block that does not take itself can return a value of that type. We also finally looked at some debugging. So we can derive debugging so we can actually analyze our structs and see what kind of current shape they have using a little bit of debugging. So that wraps it up for this video. If you like it, give it a like. In our next episode, we're going to cover enums and pattern matching. So if you don't want to miss that, make sure you subscribe. If you have any questions, please pop them below. All the links, including the code, will be added as resources in the description. Thank you for watching this video, and we'll see you in the next one.